Hello friends, I, Mrs. Sujata Dudhe, Assistant Professor from Sinhagad Institute of Pharmaceutical Sciences, Lonavala. Today we will discuss about the mass spectrometry. The name itself indicates it is dealing with the mass. Here, first of all, we will see what does mass number means. It is the sum of or a total number of protons and neutrons present in our atom. It is indicated by the alphabet A. The atomic mass number is also called as a nucleon number. We will see mass number we will see with an example. Here we are taking the example of carbon atom. Carbon atom have the 6 number of proton and 6 number of neutron and 6 number of electron. Proton and neutron are present in the center of the atom and electron revolve around it. So here the 6 number of proton and 6 number of neutron are present in the center of the nucleus, and the 6 electron is situated in such a way that 2 electrons are present in the internal orbit and the 4 electrons are present on the outer side of the orbit of the carbon atom. Here the red mark 12 is written in the red mark. It indicates the mass number. It always stand on the top of the left side of the atom, and on the downside of the left side of carbon, the 6 indicate the total number of protons present in the carbon atom. So the carbon have the 12 number of 12 is the mass number of carbon and 6 indicate the number of protons present in the carbon atom. Now we will see the mass spectroscopy. What does the mass spectroscopy means? Here this process is an analytical technique used to quantify the compound within the sample to illustrate the structure and chemical properties of the different molecules, and it deals with the molecular weight of the compound. The process involves the conversion of the sample into the gaseous state with or without the fragmentation, and characterized by the their mass to charge ratio. Here the sample gets rapidly converted into positively charged ion by the electronic bombardment. Okay, what is the mass spectrum? Spectrum itself indicated we have to get a graph or a graphical presentation of plot. The mass spectra is a graph of relative abundantness against the ratio of mass to charge ratio. Here the relative abundantness is on the y-axis and the ratio of mass to charge ratio is always present on the x-axis. Now we will see the basic principle of mass spectroscopy or mass spectrometry. So here first step is the ionization process. Here we have to ionize the sample. So before the ionization we can talk regarding the sample. Which kind of samples we can use here? Solid, liquid or gaseous? Any kind of sample we can use here, but usually the gaseous ions are preferred. We have to vaporize it. So if solid is present, we have to melt it. If liquid is present, we have to evaporate it, because vaporized form of ions are always only used in mass spectrometry. So ionization is a very important step of mass spectrometry. What happened here? When our atom get bombarded with the electron, during the bombardment one of the electron get out of our atom, and atom can get a positively charge on it. That positively charged ion can be called as a radical cation or a molecular ion. So from where does it electron get? So in our source we have a electronic gun, and from that the electron get bombarded on our atom. This whole process is carried out in an analyzer. So we can call it as a ionization accelerator chamber also, ion accelerator chamber, where the pos- various electrodes are placed depending upon its charges. So the electrodes are placed in such a way that whatever our ion is formed, highly charged ion is formed, the first electrode is of positive charge, then second is of negative charge, and third will be more negative than second plate. So for for what purpose these electrodes are placed? For the setting of the direction to the molecular ion. For direction of molecular ion, still it is not break. The molecular ion is further not break by passing through the this direction. It only get a direction to from where it pass. During it passing from the analyzer, the magnet is also applied on both side of the analyzer in such a way that depending upon its charges it gets separated. Means here the electrostatic plate is also applied, which is perpendicular to the magnet. So what will happen here, the when they are passing from the analyzer, depending upon their charges, positive charge will repels and the positive will attract towards the negative charges depending upon their charges. So it will give the path to the fragmented ion to pass forward. So during the passing from the magnetic field, it's broken down into the fragmented ion and then they hit to the detector. But how they hit the detector? The compound which is having the higher mass number, that can get deflected first. The compound which is having the higher mass number or mass to charge ratio will hit on the detector first. The signal pass to the amplifier, from detector signal pass to the amplifier, signal get recorded there, and we will get a peak on a computer system. Here the I want to mention one thing, it is related to deflection. Means our radius, the pathway from its travel, the radius is directly proportional to mass to charge ratio, but it is always inversely proportional to the deflection. Means larger the molecule, less deflection will occur, and smaller the molecule, large deflection will occur. What is the use of magnetic field here? Because of the magnetic field, it will eliminate the neutral molecules and only positively charged molecule can move further. Because of the magnetic field is applied, molecule will not hit randomly to the detector and proper mass spectra will obtain. By providing the magnetic field to the charged molecule will behave differently in magnetic field because of their molecular weight. Here the molecular weight ion means the which is having the highest mass number is called as a molecular ion. And fragmented ions means it gets separated into the smaller pieces. The three principles behind the mass spectra is to measure the relative molecular masses, to know the fragmentation of the molecules, comparison of the mass spectra with the known compounds. The first we have seen in a diagrammatic form, the same it is explained here. What does it deal with? Organic molecules are bombarded with electrons converted into highly energetic positively charged ions that we call as a molecular ion or a parent ion, having the highest molecular weight. Further break up into a smaller ion, or we can it called as a fragment ion or a daughter ions. The formed ions are separated by the deflection in the magnetic field according to their mass to charge ratio, and for after that we get the mass spectra. So this is the basic principle of mass spectroscopy. Thank you.